So, some students, an easier one. What is the name of the chapter? The name of the chapter is Atomic Structure. Okay? Atomic Structure is your chapter number 3, and you can see that overall it's lecture number 21, and of this chapter is the first lecture. That's why I just mentioned there 3.1 means chapter number 3, lecture 1. Okay? I didn't count yesterday's lecture because it was just an introduction. So what are we going to do today? Today we will be doing the basic two theories, Dalton's atomic theory and parallel with modern atomic theory. Okay? So we will begin in a minute. Let me take attendance, or if someone else can take that attendance by using their cell phones, please send it to me. Okay? Take the screenshot, and then take the attendance. So this is the content of chapter number 3. You can see, as we discussed yesterday, basic concepts regarding the structure of an atom, and the very first topic is all about old concept of the structure of an atom that we call Dalton's atomic theory. After this, fundamental particles of an atom. Today we know that an atom has electrons, protons, and neutrons. So we discussed them today all two. Okay. Then a few experiments regarding the discovery of electrons, protons, and neutrons. A natural phenomenon, radioactivity is there, Rutherford experiment. All of these are the scientific Rutherford powers. So in this chapter, we will discuss about the structure of an atom. That what are the various steps through which the scientist gone through to present a structure in front of us. All right? So yesterday I told you that there was a question in the mind of Greek philosopher of that era, that what is the consumption of matter? And he philosophically means he didn't perform any experiment. He just did it over here. They were armchair philosophers. Okay? According to Mr. Democrat, each and everything is made up of indivisible, indestructible particles that he called what? Atoms. So according to Mr. Democratus, this is the ultimate part of each and everything. Atoms. A means not, Thomas means divisible, not divisible. Alright? In Greek, A means not. A by Genesis. Then, around 200 years ago, 210 years ago, in 1803, an English school teacher, he for the first time proposed the word atom instead of atomos. And what he did, he collected all the available information regarding the structure of atom, and uh, presented that information in front of us in the form of a theory that we call Dalton's atomic theory. So what Dalton did, he gathered all the knowledge about the structure of atom and arranged that knowledge in a proper way, in a particular way, in a systematic way. And we call that knowledge what? Dalton's atomic theory. Okay? So what is the first postulate? Postulate is the points of Mr. Dalton's theory. A postulate means important points of the theory. Right? Which is the first one? How many of you remember? Just recall your memory over here. Just recall your memory. Right? You focus on the same. What is that? That each and everything is composed of indivisible, indestructible particles called atom. Not atomos. He just changed the word. He just changed the word atom. Otherwise, the concept remains the same. Alright? So, each and everything is made up of small, indivisible, indestructible particles called atoms. So, he was the first one who used these terminologies: atom, elements, molecule, etc. So, the first part is clear that according to him, each and everything is made up of atoms. And according to him, atoms are indivisible and indestructible, means you can't destroy an atom. It's a kind of revision. We have done it yesterday. Alright? Point number two. Point number two is a very simple, logical postulate. If you have an element, suppose you have aluminum foil, and aluminum foil, it's an element. It means if you have a piece of aluminum foil, then all the atoms in that piece of aluminum foil would be identical in all respects. All the atoms possess same sort of properties. They have same mass. They have same density. That means they are same in each and every respect. So that was point number two, according to Mr. John Dalton. Okay, then I told you yesterday there came modern atomic theory. In that theory, the various points of Dalton were corrected. Number three, I told you yesterday that compound is formed when two or more than two atoms combine together. We know it. Like we gave an example yesterday that suppose if you have carbon and oxygen, then they will combine together to form what? Carbon dioxide. So what is carbon dioxide? It's a combination of carbon and oxygen, nothing else. Okay, what is the formula of carbon dioxide? CO2. CO2. How many carbons? One. How many oxygens? Two. So what is the ratio of carbon and oxygen? 1:2. So what is the third point? That compounds are formed when atoms combine in simple whole number ratio. We did it earlier in empirical molecular formula too, right? H2SO4, 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. So what is the ratio? 2, 1, 4. So what is the third point? The compounds are formed when atoms of different elements combine in simple whole number ratio. And the last point, What is the last point? A new thing is formed when these atoms rearrange themselves. For example, carbon is alone, oxygen is alone, but when they combine, they rearrange, they restructure themselves. And this restructuring will result what? It will result formation of a compound. So a chemical change, a chemical reaction is nothing but the rearrangement of atoms. What is the point we noted here? That during a chemical reaction, we already know it because we have studied law of mass action that matter or atoms or molecules can't be created nor be destroyed. The same point is this. Okay? What is this point saying? That you can't create or can't destroy atoms. We already know it. Because we have studied it in law of mass action. The matter cannot be created, can't be destroyed. Okay? So how the new things are forming? Just because of rearrangement of previous old atoms. Alright? The first postulate is everything is composed of indivisible, indestructible particles called atoms. Second point, all the atoms of one element are identical in all respects. And what can we conclude from point number 2? That different elements will have different atoms. Quite obvious. If we have a piece of aluminum, if we have a piece of gold, then the atoms of gold will be totally different from the atoms of aluminum, according to Dalton atomic theory. What was the third point? That a compound is formed when elements combine in a fixed ratio. This we also have done in the form of a law that we call what? A law of definite proportion. That a compound always have a proper formula. What is the formula of water? H2O. What is the formula of water? H2O. So 2 hydrogen and 1 oxygen. What is the formula of carbon dioxide? 1 carbon, 2 oxygen. So this is law. Point number 3 is related with law of definite proportion. And point number 4 is related with the law of mass action. Alright, so this was the revision. Then here comes what? Modern atomic theory. Means you can say eliminating the drawbacks of atomic theory. Right? So what is the first possibility you can see in modern atomic theory? According to John Dalton, indivisible industry. So be corrected. Now, why? Because we know that an atom can be divided into, can be split into electrons, protons, and neutrons. So the point number 1 has been corrected. And what is the correction over here? All elements are made up of atoms, which can be further divided into electrons, protons, and neutrons. Okay? And during reactions, atoms may destroy under special conditions, like in nuclear bombs, like in nuclear reactions, like in radioactivity. Radioactivity, I told you, it's a natural process in which certain elements continuously produce what? Rays. There are certain elements which produce rays. You see, they always give what? Certain kind of radiation. So in any case, atoms are destroying such phenomena. Alright? So what is the correction over here? What is the correction over here? The correction is atom is divisible, like electron, proton, neutron, freon, hadrons, mesons, neutrino, antineutrino, so many other particles are there. Alright? Second point. According to Dalton, all atoms of an element are identical in all respects. No. Why? Because we have discussed earlier we have discussed earlier that carbon 12 is a common carbon. We may have carbon in which the mass is 13, we may have carbon in which the mass is 14 or 15. Similarly, we have oxygen, then we may have oxygen 816, we may have oxygen 817. What are these? These are the atomic numbers, if you remember, number of protons. And these are the bigger ones are their masses. All of these are oxygens, all of these are oxygens, all of these are carbons, but even they are different, they are not identical, they are not 100% same. So point number 2 of Mr. Dalton proved to be wrong, should be corrected. So modern atomic theory corrected it. Such atoms are called isotopes. We have a separate topic of isotope in this chapter. Isotope means atomic number is same, atomic mass is different. So what is point to be noted here? That point number 2 of which Mr. John Dalton's theory should be corrected. And what is this? Atoms of a single element are not 100% identical. Like we have seen that they have difference in their masses. All right. Now, point number 3. So I corrected it. All the atoms of an element are not identical in all respects. Point number 3. According to Mr. John Dalton, that atoms are in simple ratio, like H2O 2:1, like carbon dioxide 1:2. But there are complex molecules like proteins, like starch, in which there isn't any concept of simple ratio. Okay, thousands of carbons are combining with thousands of hydrogens, forming carbohydrate. So, what is the correction over here? The compounds are formed not only in simple whole number ratio, but also in complex whole number ratio. Okay? Okay? Point number 4. Already discussed this one. According to John Dalton, can't be created, can't be destroyed. We know that in nuclear reactions, matter can be converted into energy. Means you can destroy atoms, and those destructive, destroyed atoms converted into energy, like in nuclear reactions, like in nuclear bombs. All of those reactions, in all of those reactions, atoms and matter they are destroying. So this is also corrected. All right. So what have we done over here? Go through these slides. Whatever I'm telling you right now, you can see over there. You can see over here. Take the screenshot. All I have explained. Okay, see the next one. Okay, see the next one. So whatever is written in red, this represents Dalton theory, and whatever written under the heading of modification of atoms, this is related with modern atomic theory, a correction of Dalton atomic theory. Okay? Read it at your home afterwards. Just take the screenshot. You have heard all of these points in one way or the other. If you have any question in it, you can ask. All right? Keep it simple. At some places, you will see that I will discuss those points. So, if you have interest, you can ask. And this you should know that what are the advantages of Dalton's atomic theory. Means if you have a topic, you write a note on Dalton's atomic theory, then what will you do? What will you do? You will write the postulates. You write the postulates of Dalton's atomic theory, and after the postulates, just to increase the weightage, write advantages of Dalton's atomic theory. Already discussed. Okay? And here is the most important slide. In your notes, you will see the topic, the Dalton atomic theory, with more or less the same points, with the same postulate. So you should remember, I told you to write it by yourself. I told you to write it by yourself. Start making notes. It will help you out in the future. Create the habit to make notes. When you make notes, it means you have learned that topic. Okay? Now, what is the latest definition of atom? The smallest unit of building block of matter. Right? So, we can, as we have seen and know also, that an atom can be divided into two parts. The central part, or nucleus, and beside the nucleus, electrons revolve around the nucleus. That part is called extranuclear region. As you can see in this picture, the central part, nucleus, and around the nucleus, electrons are revolving. How many particles are there? Number of particles are there. This slide is not for you, just to all of these are the different particles present in an atom. You can see I have just mentioned over there, electron with red color, proton with proton and neutrons are with red color. So out of so many particles, we focus on such particles. All right? So no need. So how many parts of an atom has? Nucleus and extranuclear region. So take the screenshot afterwards. Now I'm going to write on the board, see what I'm writing. So what are the fundamental particles of an atom? Electron, proton, and neutron. A very simple topic. Again, in your book, you can find anywhere. Alright? So what is the symbol of an electron? The symbol of an electron is E minus. Or sometimes in somewhere, you can also see like this, beta minus. It's not D, it's beta. What is the symbol of protons? P plus. What is the symbol of neutron? N0. Alright? What is the charge on an electron? Negative. What is its value? Its value is 1.6 into 10 to the power minus 19 coulomb. What is charge? What do you mean by charge? It's a kind of natural power that electron has. We call that natural power what? We call it, we mention it by negative value. Negative. It's not mathematical negative power. And proton also have a power. That power is just the reciprocal, is just the opposite of the electron. We call the power of proton as positive. I repeat, there is no minus plus negative positive concept, mathematical negative positive concept. It is just to mention that electron or protons are possessing opposite kind of powers. Alright? And what is the value of each proton? Has same value. Means they have same sort of power. Coulomb, full form, Coulomb, short form. What is the power? What kind of power? Neutron has no power. Neutral. No charge. It has no charge. It is neutral. You must be knowing these things because these are very basic. Now the mass. What is the mass of single electron? 9.1 into 10 to the power minus 31 kV. What is the mass of single electron? This is the mass of single electron. And this is the lightest fundamental particle. Among these three, which is the lightest? Electron is the lightest. What is the mass of a single proton? 1.672 into 10 to the power minus 27 kilogram. And what is the mass of this, a single proton, neutron? There is no any space science, rocket science in it. These are just their masses. You will have to memorize them that this is the mass of neutron, this is the mass of proton. 1.67. Here we have 2, here we have 4. Both of these are the same. So among these three, electron is the lightest and neutron is the heaviest. This is the heaviest. If you have a blank, that which fundamental particle is the heaviest? Neutron. Which is the lightest one? Electron. Okay. Now location. You can find electron in shells around the nucleus. Around the nucleus. And where we can find, where can we find protons? Inside the nucleus. In the nucleus. Okay. Or what is the purpose of electron? Electrons are responsible for all the chemical reactions. All kinds of chemical reactions are just because of what? Just because of electrons. So electrons play very vital role because they are behind all of the chemical reactions. And what is the role of proton? It plays a role in nuclear reactions. Plus, it has been given an importance, we have done it earlier. It is used in atomic number. Atomic number means number of protons. So this is also very important. So all nuclear reactions directly related with protons. And same is true for atomic number plus atomic mass or mass number. Same is true for neutron. It plays role in nuclear reactions. What do you mean by nuclear reactions? Reactions occurring in the nucleus of an atom. And what are chemical reactions? Reactions occurring outside the nucleus. It plays role in nuclear reaction and it plays in its role in mass number. If you remember, mass number is the sum of protons and neutrons. Mass number is the sum of what? Mass number is the sum of protons and neutrons. Right? So this is all about the three different kinds of particles. Now when you write notes, for example, you are going to write something about electrons. So how will you do it? You will start like this. The symbol of electron is this. It is negatively charged. Its value is this isn't that much. Its mass is this one. It is present in shell around the nucleus. It plays vital role in chemical reaction. That's all. This is all about this. Okay? So you can take the screenshot. Take the screenshot. More or less same. That is in comparative form of electron particle. This is separate. I will be quick. Take the screenshot quickly. Take the screenshot quickly. More or less same. Whatever there in the board on the board. Alright? So what is the homework? See, read. What is written here? First is common. What is the common homework every day? Whatever you study here, just bring your notes of it. Okay? So take the screenshot. You are going to study these two slides. I will show you again what are you going to do. You will go through the next two slides and you will message any two interesting qualities of atom in the WhatsApp. Well, okay, this one and this one. That's all for today. If you have any question, ask in the group. Next, we'll start the next other topic. Thank you very much. Take care.